Okay, gentlemen, the 2014 maths paper explained in detail. Here we go. Starting with the first one, I'm not going to spend too long on the first ones because they are quite relatively straightforward. If you're increasing something by 7%, it goes from 100% to 107% because it's gone up by 7%. So you're basically working out 107% of 2,600. 107% is 107% divided by 100, which is 1.07 of means time. So it's 1.07 times that. The answer is 2782. This one, type into your calculator 0.973. If there was a problem with that, please show me and I'll go over through it. This one, just a quick one, tan 31 equals opposite adjacent, so it's 5 over x, and then because of the way this works out, x and tan 31 swap places. You multiply by x, you get x tan 31 is 5, and so x is 5 over tan 31, not 5 times tan 31, which is 8.32. Circle theorems. Watch out for this one. ABC, if that's 138, that's half of it because angle at the circumference is half the one at the origin. So that means that's 69. And then for ADC, it's the alternate segment rule. You've got a tangent here, you've got a triangle here. And so where a tangent meets a triangle, this angle here is the same as the angle opposite. So that's 69 as well. So ABC is 69. Oh, hang on. Say DC, not that one, sorry. Because this is 69, that's 69 as well, and so these lot add up to 180, which means it's 42. My bad. The circle theorem that tells you the answer to A is that the angle at the centre is double angle at circumference. It's the most literal circle theorem. You just say what it is, and you have to write that out in full. What type of triangle is ADC? These two are tangents that meet at a point, which means that this is equal to this, and therefore it's isosceles. Next question is kind of tricky. Line of gradient -2 going through the point 2, 1. If you draw a little sketch, 2, 1 is here. A gradient of -2 means that it's going down 2 every time you go across 1, so it's a line that looks like this. So you can see roughly what y equals -2x plus c. We don't know what the intercept is yet, but we're going to work it out. Here's how you do it. You say y equals mx plus c is your starting point, right? That's this general equation of any straight line. We know the gradient m is -2, so we know it's y equals -2x plus c, but we've still got two variables, x and y, and an unknown value c. What we can do is we can plug in a pair of points which are on the line, which is that when x is 2, y is 1. So 1 equals -2 times 2 plus c. I've just substituted y and x here with this value of x and this value of y. So we replace x and y in the equation, and then we get 1 equals -2 times 2, which is -4, plus c, which means that c is 1 plus 4, so c is 5. And now you know what m is, because they told you in the question, that's m. We know what c is, it's 5, so the equation is y equals m minus 2x plus c. Job done. Question 6, the minimum possible distance between the markings. It's 180 centimetres to the nearest 10. So 180 to the nearest 10, the next possible value is 10 on, that's 190. The next possible value down is 10 before, 170. The bounds are halfway between the possible values. So the halfway between 180 and 170 is 175 centimetres. That's the bit that catches people out next, because when it asks you for the speed, it wants it in metres. So speed is obviously distance over time. It wants the minimum speed. So that means the minimum speed is going to be the shortest distance in the longest possible time. So the shortest distance is 175 centimetres, which is 1.75 metres, because of that thing that we pointed out earlier. And the time is 15 seconds to the nearest second. So the longest possible time would be halfway between 15 and 16, which is 15.5. So it's 1.75 over 15.5, and that's 0.113. Functions question, not too bad as function questions go. It's saying f of 3 when f of x is this. The function tells you what happens to x when you put it in, and what you do to x is what you do to anything else when you put it in. So if x gets squared and then subtracted 5 of it, 3 is going to be squared and then subtract 5 of it. You replace the x's with 3's. 3 squared minus 5 lots of 3 is -6. This time around, it's given you the function. It says when you put x in, you get 2x minus 3 out. And it tells you that when you put x in, you get 15 out. So just watch the difference in the way it's explained. F of 3 means what happens when you put 3 in. F of x equals 15 means what did you put in to get 15 out. So when you get a question like this, you say, well, what happens to x when you do f to it? It becomes 2x minus 3. So 2x minus 3 must be the same as 15. Add 3 to both sides, and x is 9. Question 8. Vector A is 11, 2. That means 11 to the right, 2 up. Vector B is 3 to the right and 1 down. If you're doing A minus 2B, you're doing 1A and then 2 anti-Bs. So you're going 11 to the right and 2 up, and then you're going 3 to the left and 1 up, and then 3 to the left and 1 up again. You could work all that out separately. Easiest way to do it is just to write it out as vectors. Now 2b is going to be double that, so doubles 3 minus 1 is 6 minus 2, and we're minusing it. So then you just do top, take away top, and bottom, take away bottom, minus minus 2 means you're adding 2, so it's 5, 4. The magnitude of vector C. C tells you to go 9 to the left and 40 up. So that is vector C. And you can see that if you go 9 to the left and 40 up, C is the diagonal of a right-angled triangle. So C squared is going to be 40 squared plus 9 squared. Now I should point out that in the real thing it does say minus 9 squared. You basically Pythagoras these numbers, but because the size of it doesn't matter, because minus just tells you you're going left instead of right. So for direction, the minus is irrelevant. Equally, if you were going to include the minus, and this is where most of the mistakes are made, when you square minus 9 and you're typing it in your calculator, you have to put it in brackets. So you could just ignore the minus and call it 40 squared plus 9 squared. That would give you the right answer. Or if you wanted to include the minus, then make sure it's in brackets, because if you do 40 plus minus 9 squared, your calculator will subtract 9 squared from 40. What we're doing is we're adding minus 9 squared to 40, which is slightly different. Either way, this has got to be a positive number. So there's 1600 plus 81, and the square root of that, when you work out C, is 41. Factorizing these. Right, two expressions, if they've got common factors, then it's just going to be a single bracket. 6xy cubed and 15x squared z, both of them have, well, if you take a look at the numbers, highest common factor of 6 and 15, that's 3. This has got x, this has got x squared, so they've both got at least an x in it. This has got y cubed, that hasn't got any y's. This hasn't got a z, this has got a z. So 3 and x are the only things that go into both. After that, what do you multiply 3x by to get 6xy cubed? To go from 3 to 6, you multiply by 2. To go from x to x, you only multiply by 1, so you don't need to say that. And there's no y cubed in there at the moment, so we need to multiply by y cubed. To get from 3 to 15, you've got to multiply by 5. To get from x to x squared, we've got to multiply by another x, and also we've got a z in there as well, so that's the final answer. This one, something squared minus something squared, you should recognise as difference of two squares. So if that's a squared minus b squared, then the answer is going to be a plus b times a minus b. In other words, the square roots of each of these added, the square roots of each of these subtracted. Square root of x squared is x, square root of 25 is 5. So it's x plus 5, x minus 5. If you multiply it out, you'll get x squared plus 5x minus 5x minus 25, and the plus 5x and the minus 5x cancel. This one, standard quadratic factoring. 1 multiplies to make minus 14, adds to make minus 5. Well, 14 is either 14 times 1 or 7 times 2. You'll soon realise that the only combination that works to add to make minus 5 is minus 7 and plus 2. Quadratic formula, obviously x equals negative b plus or minus the square root of b squared minus 4ac. Then you divide it all by 2a. And yeah, obviously, if you apply the formula correctly, you get a mark, but you need to make sure you type it into your calculator correctly. If it's going to go wrong, it'll be in the square root. It's the fact that you're doing b squared minus 4 times a times another negative number. So this bit effectively becomes 16 minus 4 times minus 3, which is minus 48. So that's 16 minus minus 48, which is 64. So you get minus 2 plus minus the square root of 64, which is minus 2 plus minus 8 over 8. And when it all comes down, hang on, something's not right there. Oh no, it's 2 squared, isn't it? Whoops, my bad. Yes, well done. So it's minus 52. 2 plus minus root 52. So the answers you get are 0.651 and minus 1.15. Watch out, it does say 3 significant figures. So if you put 0.65, you would lose a mark. If you put more than 3 significant figures in this one, if you did it 3 decimal places, in the real thing, you would actually get full marks. In GCSE, they tend to give you full marks if you give more significant figures than they asked for, but that doesn't mean we shouldn't stop you from doing it now, because you've got to watch out. Try and make sure you do the right thing. Okay, 40 people, you want to work out the mean age. So to work out the mean of anything, you add up all the values and divide by how many there are, right? Except it's in a table. So it's not simply a case of doing 80 plus 81 plus 82 dividing by 6, because there isn't one person who's 80 and one person who's 81. In fact, there's 13 people who are 80, 10 people are 81, 10 people are 82, 4 people are 83, and 5 people are 85. So we know that there's 40 people in total because there's 13 plus 10. So that's what we're going to divide by. There's 40 people involved. It even tells you there's 40 people in the start, so you know you're going to be dividing the total of the ages by 40. The next question is, what's the total of all the ages in the room? So if there's 13 people who are 80 years old, that's 80 plus 80 13 times, or a simpler way of saying that, 80 times 13. And then the 10 people who are 81 years old, their total ages are 81 times 10. And we keep doing that to get the total of all the ages of all 40 people. And so when we work those out, it's a good idea to write out what your intermediate totals are, i.e. write down what this is and then write down what that is, because when it's a 3-mark question, you want to make sure you get as many marks for working as possible in case you get the answer wrong for some silly reason. The final answer should be 81.4 to 3 significant figures. Most common mistakes are, instead of 40, using 6 because they see 6 categories. It's not about the number of categories. There's no one here who's 84 for starters, so technically there's only 5 categories. Secondly, it's the number of people that's what you need to divide by, and there's 40 people here. Other mistake is to do with what you do with these numbers. Just think there's 13 people who are 80 years old, so when you're working out the total of the ages, it's going to be 13 people are 80, that's 80 plus 80 plus 80, or 80 times 13. If you're looking for midpoints, that's in when you have grouped frequency, and that's if it was like, 65 to 70, and then 70 to 75, and then you'd be picking the midpoint. Let's say the categories were like 65 to 70, 70 to 75, and then you'd be looking for the midpoint to work out the mean, which would be 67.5 here, 72.5 here, and then however many people are in that category, you do that times that, and you'd work it out in the same way that we just did. Okay, set theory. Intersection, remember, is when you are part of both of the groups at the same time. You must comply with this rule, and you must also be complying with this rule. So what is in the rule of P? It is 2, 6, 8, and 10. What is in the rule of Q? It is 6, 7, 8, and 9. So which ones comply with both the rules? It is the good 6 and also the 8. So those are our members, and technically speaking, we should put them in the squiggly brackets, but it doesn't matter if you don't put them in. Whereas union is like the one where it's like, if you're in that rule, or if you're in that rule, it doesn't really matter. Either of them go into the union, dude. So it's like all of these guys and all of these guys go in, except you got to be real careful here, because if you put something in twice, then you're giving too much information, okay? So like 2, 6, 8, and 10, they go in. That's cool. And then like there's also a 6 here, but we've already said that. There's a 7, we didn't say that one. 8, we already said that. And 9, we didn't say that one. So like all of those, we could put like commas in between them in the squiggly brackets because they look awesome. And then to put it into the groups, you've got the intersection in the middle, 6 and 8. You've got the ones which are in P but aren't in Q over here, that's 2 and 10. And then you've got the ones which are in Q but aren't in P as well over here, so that's 7 and 9. And then easiest mistake to make is forgetting that there are a whole bunch of other numbers which didn't make it into P or Q, because the universal set is the positive integers less than 12. So you go through all the positive integers. 1, that's not in any of the groups. 2, that's here. 3, that's not in the groups. 4, that's not in the groups. 5, that's not in the groups. 6 is here. 7 is here. 8 is here. 9 is here. 10 is here. 11 is not here. And less than 12 doesn't include 12. It's less than 12. If they wanted 12, they'd say less than or equal to 12. So that's the final set. The number of things which are in the union of P and Q. N means the number of things which are in P union Q. You already listed the members, so you can go and count those 1, 2, 3, 4, 5, 6. Are these true? -1, E with a line through it, P. This E with a line through it means, well, E without a line through it means is an element of, is a member of. With a line through it means is not an element of. So -1 is not an element of P. We can look at the list of P and see that -1 isn't there, which makes the statement true. -1 is not a member of P. This one's more complicated. P union Q complement equals Norwegian 0. That means empty set. So the things which are not in P union Q is an empty set. The set of things which are not in P union Q. So the things which are in P union Q are here and here, or this list here. The things which are not in P union Q are the things which are not in P or Q, which are the ones outside. Is that an empty set? No, quite clearly there's quite a few things which are not in P union Q. So that makes this statement false. I have to apologise for this question. You won't get it in IGCSE because it's a GCSE question. This is when they do these questions and you don't have a calculator and you have to work it out. So they give you a table where you have x and then you have x squared. So minus 2 squared is 4, 1 minus 1 squared is 1, and 1 squared is 1. Remembering, of course, that when you square negative numbers, they have to be positive. If you type in minus 2 squared, it won't work. And then it asks you to write x again. This is very strange, and why would anyone do this? You've got a calculator which can work it out. And then the final result is y, which is where you combine together, effectively you're adding together these three columns, x squared plus x plus minus 3. Of course, the easiest way to do it is on your calculator. I'll just get one. Ta-da. Standard issue, FX85GT Plus. This is probably the best calculator to use for GCSE. Other calculators are available. What you need to do is you need to go into table mode. So you type in mode, you pick the one that says table. That's part number 3. Then it says f of x equals. You type in x squared plus x minus 3. How do you do that? You use x, which is alpha bracket, square it, add alpha bracket again, minus 3. It then asks you start. That means where did the x values start? Minus 3. Use equals like you would, sorry, I'm off screen here. Type in minus 3 and then use equals like you would use enter on a computer. It then says end, that's your last value, x value, that's 2. So type in 2 equals, it then asks step, which is probably the least confusing one. It knows you're starting at minus 3, it knows you're ending at minus 2. It wants to know how big are the gaps. Because obviously it could do loads of numbers between minus 3 and minus 2, like it could do it every 0.1, or it could skip some. This typical step is 1, which is why there's already a 1 there. So you can either press 1 equals, or you could just press equals, and now it gives you the table. There are your x values on the left, there are your y values on the right. So you can see the first y value is 3, the next one's minus 1, the next one is minus 3, the next one is minus 3 again, which is good because that's what we've already got on the table. The next one's minus 1, and then your table's done. So you plot the graph. There's the points. And to join it up, just be a little bit careful. I'm going to do it freehand for the first bit, actually, which is probably a bad idea because my drawing is pretty terrible. Look at that. That's awful. If your drawing is as bad as mine, then I would carry on like this. I would draw a little... You do it in pencil for a start. I shouldn't really be doing it in pen. But do like little dashed lines in between the points, and then you can join them up afterwards, and it just makes your curve a little bit smoother. That's still not great, but that's better than it was. The key thing is here, you've got 2 points which are level, and the temptation is to draw a flat line across. If you do, you lose a mark. It's a quadratic. Quadratics are Pharrell happy face. There's Pharrell with his hat. Ta-da. Actually, that's more like a sombrero. Anyway, point is, it's got to be curved at the bottom like a proper happy face. And that's a terrible graph, but it wouldn't lose me marks, I hope. And then you've got to solve some questions. This is the tough part. To solve these questions, right, you've got your graph here. If your graph is here, that makes the question easy. When it says solve the equation using a graph and it's written down the same thing as you already drew, y equals x squared plus x plus 3, then all you need to do is draw y equals whatever's on this side. So we're going to draw y equals 0. Y equals 0, hopefully you'll know, is the x-axis, is this line here. So it's basically saying where does this graph cross the x-axis, and you can see it's, well, if you've drawn it well, it's minus 2.3 and 1.3. Mine actually looks like 1.4, but they allow a bit of tolerance on this. Usually one square either side, so I would have got the mark if I'd written 1.4, because that's actually what I got. Then it says, by drawing a suitable straight line on the graph, solve this. Again, is this your graph? Yes, it is. If it's your graph, you draw y equals whatever's on the right-hand side. So we draw y equals x minus 1. How do you draw y equals x minus 1? Well, again, you could just cheat and get your calculator to give you the points. So we type in f of x equals x minus 1, start minus 3, step 2. And you notice that all of these steps are actually in here already. When you press AC on graph mode, it doesn't delete your information. It goes back to the beginning, so you could tweak things if you wanted. So I could change the start or the end or the step if I wanted. So there's all my points. But, I mean, we should know how to plot that. The thing to be careful of here is that it's easy to see y equals x minus 1 and think, oh, goes through minus 1, has a gradient of 1, so it's going to look like that. But, of course, on a quadratic, they're going to change the scales. So this goes 1, 2, 3, 4. This goes 1, 2. So it's not going to be a classic 45-degree line. It's going to look like this. So there's the line. I'm going to just sketch one just to save time. It looks like that. And it goes through the points. Yeah, you see, I haven't drawn it beautifully here. It says here in the answers 1.4 and minus 1.4. I have a feeling it's a bit, that's not quite right, actually. Yeah, Yeah, have I drawn something horribly wrong? Yeah, I've drawn, okay. Did wait, I've completely messed this graph up, haven't I? Oh dear. Sorry, yeah, the graph should look, it's embarrassing. That's why it didn't look quadratic. The graph should look like that. Oh dear. If I'd drawn it in pencil, I could have rubbed it out, but now I've got to leave my mistakes on. There you go. So yeah, this is looking like 1.5 and maybe 1.5 again for me, but apparently the answer is 1.4 and minus 1.4. Just shows you should take a bit more care over these. Apologies. Now this one's difficult. This last one, solving the equation in this straight line. You'll notice it's not the graph. So when it is the graph, you just draw y equals whatever's here. When it's not the graph, it's a bit more complicated. And the rule is that you go from the question to the graph, or quack to goose. I don't think that will help any of you remember it, but there you go. So from the question to the graph, you write the graph underneath. The graph is x squared plus x minus 3 underneath the left-hand side. How do you get from the left-hand side to the graph? From the question to the graph. So from 2x to plus x, we've dropped an x. And from nothing to minus 3, we've taken away 3. So we have to do that, the same thing to this side. Now, if you take off an x, there's no x's to begin with, so you're going to be minus x. And 2 take away 3 is minus 1. So the line we would need to draw is y equals minus x minus 1. I think that's probably the hardest question on the paper. That's a real tough one. Onwards. Simplifying this, you're multiplying them together, so the whole numbers you multiply like normal. 9 times 2 is 18. And 8 to the 2 times 8 to the minus 1, when you multiply two indices with the same base, you add the powers. So it's 2 plus minus 1, which is 1. You don't write the 1 though, you just say 18a. Here you've got some fractions. When you're dealing with fractions, you can only add or subtract if you've got a common denominator, so put them both over 20. X over 4, would you multiply the 4 by? You multiplied it by 5, so you're going to multiply the top by 5, we get 5x. To get from 5 to 20, you multiply the bottom by 4, so we're going to multiply the top by 4 as well, which means we get 8x. So it's 5x minus 8x over 20. When you have two fractions with the same denominator, you can click them together, put it all over 20, so it's 5x minus 8x over 20, which is minus 3x over 20. We've neglected the right-hand side all of this time, and we haven't actually changed the left-hand side, we just combined it. So now we've got minus 3x over 20 equals 1. Multiply both sides by 20, this disappears from the left-hand side, this becomes 20, and so x equals 20 over minus 3, or minus 20 over 3, which is 6.6 recurring. If you leave out the dot, because your calculator will just do 6.6. If I type it in now quickly, mode 1, sorry. If we do 20 divided by minus 3, I'll type it in as you might type in. Oh, I'm in true false mode, how did I do that? Sorry. 20 divided by minus 3, and then SD it. That dot is pretty hard to spot, and if you leave it out, your answer's wrong. So do be careful with that. Easy mistake to make. Remove the brackets and simplify x minus 7 squared. This is pretty important because it comes up in a couple of other questions as well. X minus 7 times itself. Multiply out the brackets however you want, eyebrows, smiley face, whatever. And you get x squared minus 7x minus another 7x, which is minus 14x. And then minus 7 times minus 7 is plus 49. Writing as a single fraction. Again, more difficult here. These don't have a common factor. So the only common denominator is when we multiply them together. So it's going to be x times x minus 1. I know that not many people got this one right. So the bottom here, we've multiplied x by another x minus 1, so we do the same to the top, so it becomes 5 times x minus 1. And then we're adding, what do we do to x minus 1 to get x minus 1? X times x minus 1 multiplied by x, the top becomes 2x. Effectively, you are cross-multiplying, although remember there are cases where you don't do that, but that's not this question. So then we click these two together because they got the same denominator, so putting it all over x minus 1, we've got 5 times x minus 1 plus 2x. Expand those brackets, you get 5x minus 5. So 5x minus 5 plus 2x equals 7x minus 5 over x times x minus 1. And that's the final answer. Right, so here's a chance to make some p's. We square both sides. We get 2p plus m when you square it. And then to make the subject, p the subject from here is pretty straightforward. A squared minus m. And is 2p, and then divided by 2. So it's just a squared minus m over 2. Not too bad. Here's where it's difficult. Yeah, obviously when you've got loads of p's, that can be a bit of a problem. And so where do you stack them? The important thing is when you're stacking your p's, you've got to make sure they're all on the same side. Make sure anything with p in it is on one side, anything that doesn't have p's in it goes to the other side. That's how you protect your p's. So adding and subtracting is what you need to do, provided you've got rid of all brackets and fractions. There's no brackets and fractions involved in this question. So it's simply a case of adding and subtracting to move all the p's onto one side. I would say move it doesn't really matter, move the AP's over to this side, so we get 5p minus AP, subtract AP from both sides. And then, shall I add 2 at the same time? No, I'll do that as a next step. So minus AP, and we get 0 on both sides, and then we add 2, we get 5p minus AP equals 2. Now, you've got all your p's on one side, so now you can factorize, which is how you turn 2 p's into 1. And then once you've got the factor, you just divide it. So p is 2 over 5 minus a. Right, what you do with indices. This is a root, and roots and indices are done with fractions. So the cube root is going to be x to the power of a third. This one is a straightforward one. It's x to the minus 3, and then when you divide, you subtract powers. It's minus 3 minus minus 1, which is minus 3 plus 1, so it's minus 2. So that's x to minus 2. When you flip with indices, that's the reciprocal, it's a minus. So this is x to the minus 4. Sheep. Right, you start off with 3 male sheep out of 15 and 12 female sheep out of 15. If you take away a male sheep, instead of having 3 male and 12 female, you've got 2 male and still 12 female, but there's now 14 sheep. That's probably where most people drop marks. And if you took away a female sheep, instead of having 3 male and 12 female, you're going to have 3 male and 11 female out of 14. So that's how you complete that. In probability, unlike in other situations, you tend not to cancel the fractions down. It just makes it easier to compare the probabilities. So the probability of picking 2 male sheep, that's a male sheep followed by a male sheep, and as you go along the branches, you multiply. So it's 3/15 times 2/14, which is 6 over 210, which cancels down to 1 out of 35. If they're different sexes, then either the first one's male and the second one's female, or the second one's female and the first one's male. So it's going to be 3/15 times 2/14 for the first root, or, and when I say or, I mean add, because you multiply as you go along the branches, but whatever the result is, you add it together. So it's going to be that plus this one, and when you add that all together, you should get 12/35. A third sheep is picked at random. Find the probability they're all female. It doesn't mean you need to do branches for all of the different possibilities. You just need to work your way down this branch. First is female, second is female. Now, it was 3 and 12 before. You took a female out, now it's 3 and 11. You take another 3 female out, it's going to be 3 and 10. So there's going to be 10 female sheep left out of 13. And then you multiply down the branches. So it's going to be 12/15 times 11/14 times 10/13, which is 44 over 91. Lovely. Next one. X is greater than or equal to minus 2. The line x equals minus 2 goes through here. Is it shaded? Yes, it is, because it's got the equals underneath. Is it a solid line? Yeah, because it's got the dotted line. It's not dotted. This one is dotted because it hasn't got the equals, so you draw y equals minus 1, but you dot it. And then x plus y is equal to 1. If you want to work out what x plus y equals 1 is, you can do the cover-up method. When x is 0, y has to equal 1. And when y is 0, x equals 1, so it goes through those 2 points, which means it looks like this. Now we've got to work out which side of the line is it. Is it solid, by the way? Yes, it is, because it's got the equal sign. Well, we want to be more than 2, so we want to be this side of this line. We want to be more than minus 1, so we want to be this side of this line. And we want to be less than 1, so we want to be underneath this line. It's almost always the triangle in these questions, even though it shouldn't necessarily be. So that's the region that we shade, or we can shade in everything else and leave that one blank. It doesn't really matter. Directly proportional to the square root of t.